Hello, welcome to this series of lectures on computer networks. This course were designed in two parts. In the first part of the course, which we call basics, we would cover primarily topics that will enable us to use networks in a better way. On a daily basis, we'll understand how does network work, what is involved, what the different applications are, their workings, how do they communicate, and so on. In the second part of the course, which we call advanced, we will look into nitty-gritty of networks so that in case you want to design, debug, implement, look at the performance part of it, and make a robust and better networks, then we'll do the second part. So let's get started. Network, in my view, is my own acronym, and we can look at studying network. Those lot of students I talk to, they say it is a dry subject, it's abstract, very hard. But to me, it is a novel way, and as you see from the acronym, it is a novel experience of theoretical, working, operational, and realized knowledge. So, N E T W O R K, that means if you really want to study network, you should be able to get novel ideas, you should be able to experience it, though we don't undermine theoretical part because that makes the foundation. You should be able to do something to see network works, operate things, and once you do that, you realize the way of working, and that's how you develop the knowledge. So, as part of the course, as usual, any course requires some textbooks, and in this course, we primarily focus on the textbook The Computer Networks by Kuros and Rose, which is one of the very good book, and primarily this text, the course will be depend upon this. The other books by Peterson and Davis, fifth edition. For the Kuros and Rose, sixth edition is available. And then for exercises, refer to the book of Forozen. Of course, there are other support materials. We have RFC, it's called Request for Comments. There are about 8,000 right now. All the internet standards are primarily defined by RFC. Not each RFC is a standard, but some RFCs which have been accepted well have become the standard. And of course, there are enough reference materials, most of them cited in these books, to make sure that we understand the network by learning, by conducting experiments, and what we call is experiential learning of networks. I've been writing a series of articles in the magazine called ACC.digital. It's available online. Print copy is also available. You to subscribe. But online lectures, online topics, articles are accessible free. A summary of these articles, the ACC.digital basically gives you the current article, but if you want to look at summary of this, I maintain a reference on my personal website which gives you all these articles I written in this subject. And of course, as my first reference book by Kuros and Ross, they have the website which give very informative and learning exercises which is given in this. So those who want to learn, conduct exercises, interactive, the video lectures, the simulation, and lot more resources. So I would recommend to visit and learn from there. So what we'll cover in this course and how do we go about it? Like to do any work, if you are doing plumbing, you need to have tools. For electrician, you need to have electricity meters, you need to have the ammeter, measuring instrument, voltages, or multimeter, other stuff. If you want to cook something in the kitchen, you will have to all the utensils, tools, pots, stoves, and all that. Same way, to learn networks, rather than learning to theory, we would like to understand practically. We should become aware of different tools. And first and most important tool I suggest is understand the wires arc. It is probably we call Swiss Army's knife, Swiss man's army knife, which can do a lot of things. So this is one of the most important tool, and if you can learn how to use this tool, it will be very very useful in subsequent life, whether you do a job, to debug applications, to look at the communications, and you'll see this tool, use of this tool, if you can understand, will always help you and rescue from all your troubles. There are other associated tools called netcat, which is called NC. That means you can communicate at the basic level. So NC as an application or a tool, you can communicate using network with no application overheads. Then ping stands for packet internet grouper, which is primarily to check reachability and do network diagnostics. Traceroute will help us identify all the routers from A to B. We can use this to find out how much time it takes from each one place to other and what each hop. And of course, you want to access machines, login called SSH secure cell or secure copy. And those who want to work at the command line, not at the graphics, like WhatsApp is a graphic tool. There's a command line tool called TCP-dump. So you can say WhatsApp is a graphics built on top of TCP-dump, and most of our experiments would be designed around involving Linux operating system, and with some I would recommend you to learn basic shell scripting as well. All the lectures would be always provided with some case studies. So unless you work out the case studies, spend time, solve the problems, it will probably remain a theoretical knowledge. But once you take time for the exercises, and I would recommend do the exercises with a team, find a partner, spend, discuss. You learn by more discussing and teaching rather than doing own. So make a team with your friends, work together, solve the problems, implement it, and this will basically help you learning this subject in a much better way. Are there any prerequisites for this course? As far as officially concerned, you don't need any other course as a prerequisite, but expect to have basic, very, very basic knowledge of mathematics, which will be very simplest level of probability theory, like when you toss a dice, what the probability of getting a even number or a getting an odd number or some at the basic level. Of course, when we deal with IP addresses and managing those, looking how packets get routed, we would be dealing with binary mathematics. So please revise your binary mathematics. Like in binary mathematics, if you know the digit 2 is written as 1 0, digit 3 would be 1 1. So this is decimal 2, this is decimal 3. Digit 5 is binary 101. Similarly, digit 10 is 1010 decimal 10, and binary is 1010. So I would recommend learn or revise binary mathematics. That will help you. As I said before, most of our exercises will make use of Linux. That doesn't mean you can't use Windows. So you can have Windows running by default as a desktop. You can install VirtualBox or VMware and have a Linux as a virtual machine and run these commands, because it becomes much easier. Linux gives you a lot more power to play, understand networking command, and that's the reason we'll be using Linux as a base. Somewhere in the course we'll also be doing what is called socket programming. That is when application A on machine A, when application X on machine A communicates with application Y on machine B, what kind of network interaction they do, network API they call, and that is what is called socket programming. So we'll do that, and we're doing socket programming. We'll basically use Python as a programming language. It's a simple language that you can understand and practice. We'll not go into details, but very simple one. So let's start with this background. We what is we going to study? We'll basically look at network today. You talk to anyone, network means internet. Though the TCP/IP network, what we call today, originated way back in 1980, the internet as we know it started in 1990s when the browser came in, when the Tim Berners-Lee, the HTTP protocol involved, and since then we treat network as synonymous with internet. So we like to study what is the network architecture, what it consists of, how do people access it, what is inside the network. When you communicate with somebody, for example, sending a message on WhatsApp or sharing something on Instagram or communicating, sending an email, how does the data go? We look at the everything we look at the goes as packet switching. So whole network as we look at TCP/IP is packet switch based to understand packet switching and how the routing takes place. Of course, voice calls typically use circuit switching. We get a very basic idea and see why packet switching works better for network case. We will also study different protocols. For anybody to communicate, we need to have basic rules of communication. And similarly, when application is to communicate in a network, what are the protocols? We study those. What is this service network gives us? What do we expect? What are the various models for different layers? And we look at that. We know that whenever you send a message, email, it sometimes doesn't go immediately, it takes a while. Your WhatsApp text may take few milliseconds, seconds to deliver. Sometimes packets are lost, network is lossy. You're talking something, the 3G goes out, you can't send a message, you retransmit. So we look at packet loss and how does our network recovers from this. So essentially, if you look at the internet is the largest man-made engineering structure. It was not natural, it was designed by human beings. It was started in US, funded by DARPA, Defense Advanced Research Project Agency, and though it started with US, but today its growth is contributed by each and every one of us in the world. The population of the world is about 7.5 billion, and we know that we have more than 50% people using internet. So we need to look at to internet. We like to know how do you approach studying it, what are the principles that guides the packet it's governing, what is its basis, how do we construct it, look at all those sides. So before we get into that, just trying to look at what is the size of the internet. We know Google, we know Facebook, we know Instagram or WhatsApp, something. How many such domains exist? How many domains people reserve but not in use? So all these like Facebook, Google, Instagram, these are all the websites. So how many websites exist today and what have been existing before? So the website called netcraft.com, you can visit there. It gives you the basic summary. So I suggest you to visit that website. Look at this website. It gives you a details of how many websites are registered, exist, and how many websites are actually operational. So data as of May 2019 is we have different kind of web servers. We probably see we're close to more than 1 billion hosts and registered, but probably 120 or 118 million, 180 million websites are actually active. Now, when we access, we know how to use a browser. We use browser like Internet Explorer or the Edge, or we use Chrome by Google. Those use Mac, we use Safari or Firefox. This is the user side. But on the other side, which is the application server that the Google or Facebook or other machine runs, the primary there are three different web servers that dominate the market. One is called Apache, which is open source and we can download and install. Another one is Microsoft IaaS, that today are called Microsoft the Internet Server, which is today as of May 2019, 19% websites deploy Microsoft IaaS, Internet Information Server. Apache Web Server is by 29%, and then you have Nginx, which is the new king on the block, which has almost caught up to become the at par with Apache. And of course, there's a server by Google and other different entities. So I would recommend that to go to the site, look at what are the current, go to the site of Netcraft, look at what is the current market share, what the current host name, and update yourself. At the same time, when we see a web page, it has a lot of images, it has a lot of active elements, responsive websites. So typically what a website consists of, what is the each website is, how much time it takes, what kind of the issues, the directions. So there is a good information available called htbarkai.org reports. So I would recommend you to go there. You probably get the basic idea of a structure of a typical web page that it consists of. So as a first exercise, I would recommend to visit the Netcraft website and identify the number of total domain registered and total number of active hosts which are existing, and look at its history, how it has evolved, look at the market share. So for last 2 years, how it has grown month on month basis. Is it always that they were like this? Is it always that Apache was always 29%, or has it been more or less? You'll probably go back 5 years, you would see Apache has 60% market share at some point in time. So analyze, equip yourself to know history of how the websites are performing. Look at the market share of Apache, Nginx, and Microsoft as well last 2 years. That will give you an idea. Having done that case study, we'll probably look at the internet. How do we use it? So my recommendation is you can pause the lecture now, visit these two websites. One is the netcraft.com, which is what I said, netcraft.com, which is the website, identify the number of active domain, and then look at the website called your htbarkai.org and look at the web page structure. Having equipped yourself, resume the lecture to understand where we are. So we'll look at as internet, how do we use it today? Initially, there were only PCs and desktops or laptops. We use it from there. But today, most of people use smartphones, like iPad, which is a tablet, or even phablet, which is both phone and device. But now, internet is not limited to just iPhones or Android phones or your tablet, iPads, or your the PCs or desktop. It has gone to home appliances. For example, your fridge or air conditioners. You know that you can enable turn on your air conditioner, the room air conditioner remotely from your office. You can cook things in toaster. The fridge can communicate and say things on. Your car can indicate to the service center that might needs a service. So a lot of appliances and internet is being enabled now. In the entertainment industry, your set-top boxes, your TV is internet enabled, your gaming console, which is a big business. In fact, I normally joke, if you want to choose an industry, to be make sure that your career is foolproof from any industry recessions, choose game development, because it doesn't matter whatever happens. Gaming industry will always thrive. You always have kids who like to spend money. So if you want to build a good career, gaming industry could be one of the choices. And now internet's percolated to wearable devices. We have the iWatch or the Fitbits that we wear, all the health rings that measures our BP, communicate to the doctor, makes a medical record. You don't you look at the now is percolating on further, your light bulbs, your water fans, your geysers, you name it, anywhere. So primarily is gone to IoT devices, sensors. So internet is percolating all through, and that's where it is. So how did internet really evolve? At the start time when internet started in about 1990, it was all person oriented, targeted towards a human. Data was primarily text, little bit of images, and that's how the internet was. So primary before 2000, 1990 to 2000, the first decade, which we call internet 0.0, you want to call it, it consists of static pages. Then somewhere around late after 95, 96, when browser came in, it became active, it became dynamic. So companies started giving you dynamic information based on the user. You look into the account, see things up, dynamic information, product information. Then in the next decade, 2010, we got dynamic content individual. I record a video, upload it on Facebook, or make a content, up short video, YouTube. We got into mode of social computing. We have crowdsourcing. A lot of people can get idea from crowd. And now today, if you look at internet, it's primarily it's become IoT oriented or Internet of Things. So not even humans, though it started with humans as a consumer, now machines are actually consumer, and the internet is today, and most of the internet today are not from the desktop, but from the mobile app. And the key focus of the internet today is how do we keep the user engaged? Expectations have become very high. On a browser, if you don't get a responsive page within 2 seconds, you get distracted, you like to switch. In fact, if any response takes more than 3 seconds, and if you have a choice, you are likely to move out, go to a different website. So how to make it performance plays a key role, and we'll need to look at that part. Even the internet started in a distributed way to support any kind of fault tolerance, but travesty is it has become today practically centralized. Why we call it centralized? Because internet is kind of confined to today or limited to maximal usage. Internet revolve around using Google, Facebook, Twitter, YouTube, Instagram, Amazon. So when we access internet, probably 80 and 90% time we are accessing these websites. So that's what internet today is. Now, what internet has given us, if you look at previously, it was company giving information and we were consuming it. So if you have a newspaper, what published in the newspaper is decided by the newspaper industry, the company that produces the newspaper, like Times of India or the Hindustan Times or the Hindu, the Deccan Herald, or TV programs. It is the channel creator decides, Times Now or Republic or G News, they decide what content is to be created, seen, and your only choices. But internet has enabled each one of us to produce content. I can simply record a video, upload on YouTube, let anybody watch. So in a way, it has equalized, made a level playing field. Anyone can do that, as long as the content is interesting, and you can attract, you can become a celebrity overnight. So it creates, enables your creativity in a big way. And you, if you create a tweet, if it's good enough, people retweet it. So in overnight you can become celebrity, and that means internet has made you create a level playing field where each one of us can prosper and grow. Of course, with this each one being enabler, people do misuse it. So to have a better internet used, we do need to define some social norms. It's something like if you're talking to someone you don't speak is considered bad. Same way, like WhatsApp today, I'm texting somebody a message, but don't get a response. I think my person is not listening to me, ignoring it, you feel bad about it. So we need to understand the current social norms. There are pros and cons. Understand those. People try to bully you, bring you down. People do get depressed. So to live with it, understand those, and make sure you use internet in a proper way. Of course, along with that, with concerns of security, data theft happening. Today, as you healthy world, data is the new oil. So data decides. So typically what we say when you read a page on an iPad or an iPhone, we think we are reading a ebook, but in reality, it is the iPad or the your Android phone is reading you. It knows when you turn a page, when you scroll up or down, which paragraph more interesting to you, and those kind of things. And of course, there are hackers out there who basically becomes man in the middle, what we call MITM issues. If you are not aware of lot of things, your personal info may be stolen by the hackers without your knowledge. So we're looking at the internet, as you said, it is the largest engineering entity created by mankind. We like to study how does it work, what are the guiding principles, who governs it, who owns it, who manages it, and how do we describe the internet? Do we describe it in terms of physical boxes, or do we in terms of how this communication happens, or what kind of services it provides? So we'll look at these view, and that probably do in our next lecture. So till that time, I would say for those who have not done the exercises, do the exercise, case studies, and equip yourself with how the internet is. And look in the next lecture, we'll look at the nuts and bolts view and services view and the protocols view.